Hello everybody! In this lesson, we will review the concept of software reuse. We will introduce the main formal pillars to reuse software. So let's start! Firstly, I would like to remind you the definition of the software reuse. Software reuse is commonly defined as a process to systematically specify, produce, classify, retrieve, and adapt software artifacts for the purpose of using them in a development process. In the previous lecture, we have introduced the magic ring for software reuse as an easy tool to present the notion of collaboration between software artifacts. Obviously, this ring is supported through the following formal pillars. The first one, abstraction. It refers to the management of the intellectual complexity of a software artifact. How are we going to represent the functionality of a software piece? The second one, selection. How we can find such a software? It is necessary to represent, store, and provide a retrieval mechanism based on the metadata of the software artifact. In this way, we can compare and select the most proper one according to our needs: latency, cost, stability, provider, scalability, elasticity, flexibility, extensibility, performance, and any other quality factor. However, although we can find the required piece of software, it is possible that it only covers part of the functionality we are looking for. In that case, it may be possible to customize a software artifact according to our needs. Finally, the last pillar is integration. In that case, we can ask again ourselves several questions. Is the software artifact built on standards? How much effort we have to do to integrate this software into a system in which it must collaborate and communicate with other parts? This is a quite hard objective to reach. We should focus on software based on standards, that is, well documented and with a huge community behind. Otherwise, we can find that the effort to integrate a software piece is bigger than the development from scratch. We can therefore conclude that the reusability factor of software artifacts will directly depend on how they are abstractly described, how they can be selected and specialized for reuse, and how they will integrate in the new complete software system. In general, the software industry gets inspiration from traditional industries, such as car manufacturing. In the early 20th century, modern assembly and product lines were introduced to build the first mass-produced automobile. Henry Ford introduced this manufacturing method to save costs, improve the performance of factories, specialize workers, and enable a system of continuous production. This method required to model the common parts and steps that will be applied to all types of cars, while other states will be only used to customize particular parts of some cars. In the software world, we can find a similar approach to create software factories, in which software can be massively produced. Two main approaches can be found. Software product lines. Similar to the approach already presented in car manufacturing, software is designed and developed depending on a set of common features, commonalities, and another set of variables, variabilities. The main idea of this approach is to model those features to allow the software development process to be divided into different stages in which features are added. The task of identifying commonalities and variabilities has been a widely researched area. Many authors claim different methods to identify features and to group them in the appropriate artifacts through components or services that are then exposed as an API, Application Programming Interface. In general, a component is a software package, a web service, a web resource, or a module that encapsulates a set of related functions or even data. Therefore, this method emphasizes the separation of concerns with regards to the wide-ranging functionality available in a given software system that are assembled together to produce the whole system as a combination of individual components that can be reused. Software interoperability. Recent times have seen the deployment of new methods to boost the concept of continuous and collaborative engineering. Under this view, the software development process can be seen as an iterative process in which the artifacts generated must collaborate together and exchange data and information. The main idea relies on sharing data, so tools and applications communicate each other under certain protocols and standards. In this context of software and system artifact reuse, the Open Services for Lifecycle Collaboration, OSLC, is a joint effort between academia and industry to boost data sharing and interoperability among applications. They apply the linked data principles to take advantage of web-based standards such as the Resource Description Framework, RDF, and the Hypertext Transfer Protocol, HTTP. This is also known as Internet of the Tools. After presenting these two main approaches for software reuse, a new question comes to my mind. What it can be reused? Well, in general, it depends on the domain and application. It is possible to reuse low-level and isolated artifacts, such as source code, requirements, or test cases. Components, or libraries of components, through a predefined API, are the most common approaches to provide software reuse. In other cases, a whole architecture or system can be reused through application generation frameworks that, taking as an input a set of configurations for a particular domain, can automatically generate the whole system. In this lesson, we have introduced the principles of software reuse: abstraction, selection, and integration. And we have outlined two methods for software reuse, such as software product lines and interoperability-based reuse. Furthermore, we have introduced some mechanisms that can help us to select the best component according to a set of quality characteristics. These pillars should ease the task of software reuse and make easier the decision on reusing existing software artifact, or make our own software system from the scratch. I hope you have enjoyed this lecture, and see you in the next videos.